chemical kinetics. It involves mathematical evaluations. We know the expression for the orders of the reaction for the zero order, first order and second order, which the derivations we have done in the last class. This is the one for zero order, first order and second order. These equations find application if we know the time required for completion of certain amount of reaction, a known amount of reaction, which may be in the form of concentration, molar concentration or percentage. If that is known, we can able to calculate the time taken for completion of any other amount of reaction we wish to do so. So now the problem is set on these equations. The time taken to complete 10% of reaction is 4 minutes. Calculate the time taken to complete 90% of reaction. Here with the same data, 3 different problems for zero order, first order and second order. First you write the given data in the appropriate way. If we say in terms of percentage, A becomes 100. A is initial concentration, 100% it means. Here time taken is 4 minutes. Reaction completed is 10%, that is x equals 10, completion of reaction. Then the remaining concentration is A minus x, that is 90%, 90. This is for this. Calculate the time taken to complete 90%, that is T to be calculated when x equals 90%, 90% completion of reaction. The remaining concentration is A minus, that is A minus x is 10. So with this data, let us go for calculation. Take the zero order equation. For zero order, if the reaction is zero order, what is the time taken to complete 90%? Suppose the reaction is first order, what is the time taken to complete 90%? For second order, similarly. Take the equation, substitute the data and simplify, that is all. Here x by t, k equals x by t, no A minus x term here. You know the value of x and t. So for this one, no, x equals, that is k equals 10 by 4. For 10% completion, 4 minutes. The same equation. For 90% completion, time that we don't know. Equation remains same. K. So right hand side should be equated. Left hand side are same. Equate the right hand side. So when you equate it and simplify t equals this 36 minutes. If the reaction is zero order, it takes 36 minutes to complete 90% of the reaction. This is the way of calculation. This is one problem. In the same one, what is the second problem? For a first order reaction, what is the time taken? Equation for a first order is this. Write the equation with this data. K equals T equals 4 logarithm of A by A minus x. A is 100, A minus x is 90. Equation 1. For this one, same equation because reaction remains same. T, which you don't know, logarithm of 100 by 10. That is A minus x is 10. So left hand side k, equate them. This equals this. Equate them and simplify. So this is the one. When simplify, this will cancel, and logarithm of cancel. This logarithm 100 by 10 equals 10. Logarithm of 10 is 1. This becomes 1. T. Take t to the left hand side, goes to numerator, and this 4, numerator of this denominator, log of 10 by 9. Log of 10 by 9 is 0.11. Logarithm of this value is 0.0441 and this divided by this is equal to 96.2. So the time taken for completion of 90% of reaction is 96.62 minutes if the reaction is first order. Look at that. If it is second order, let us see what is the calculation. Equation for the second order is this. K equals this is the one equation is well known to us. So write the same data into this. First one K, T equals 4, A minus X equals 90. This is 1 by A 100. 1 over A minus X. This is the one into this equation. And this is the one into the same equation. T not known. This is for 90% completion, 10% remaining. 1 by A 100. Equate them. This equals this. Simplify. So this is what you can take out 1 by 10. 1 by 10 cancel. Here 1 by 4 remains simplify, simple mathematics. And you have to simplify by taking LCM. This is 1 by 90, 9 by 10. T is equal to, take T to the left hand side, numerator, all the remaining to the right hand side. So this 4 into 9, this is 90, 10, 9 it becomes, cancel, 9 and 1. 4 into 9 into 9 equals 324 minutes. So T equals this value. So this reaction, second order reaction, if the reaction is second order, it takes, what is that? 324 minutes for the completion of 90% of the reaction. So this is how these equations find application like this in the problems. This is one set of problems. In the similar, what is vice versa class, you can calculate. If you know the time, if you know the percentage, you can calculate the time. If you know the time, you can calculate the percentage. That way also is possible using the same equations. Next set of problem, second problem, it is a calculation of order of reaction for this equation, general equation. This is a chemical equation, generalized. This is the rate expression for this equation. It is an expression where X and Y are experimental evaluation. It is possible by experimental evaluation. So for this we need what is our experimental data. We have this data, experimental data for this reaction. There are two sets of experimental data are there, two problems on this equation. With this data, what is the order of reaction? Suppose the data is this, what is the order of reaction? Calculation. This is the equation, R is equal to K into e to the power of X, b to the power of X. Let us calculate the order of reaction for this data. If the concentration of A doubles, the rate doubles. That is the one for this one, is it not? Here only concentration of A is mentioned, concentration of B is not mentioned. That means it is kept constant. The concentration of B in this sentence, it is isolated. So if that is the equation, concentration of B is kept constant. This constant into K is equal to another constant. The equation is reduced to this for this data. Rate of reaction is only concentration of A. This exponent. So the data is concentration of A doubles, the rate doubles. This is the rate when the concentration of A is A, rate is R. When the concentration of A doubles, that is 2A, A becomes 2A, R becomes 2R, rate doubles. Writing is very important. This is the one substitution into the equation. This is the one for when concentration A, rate equals R. When the concentration is 2A, rate is 2R. These equations. in terms of what is that? Rate of reaction is a function of concentration. Here. Simplify this simultaneous equation, divide one by the other. Left hand side by left hand side. This by this by this. Simplify. You get this R cancel, A cancel. 2 to the power of 1, 2 to the power of x. These are bases, exponents are equal. X equals 1. That is the value of x. This is how we have evaluated the value of x. Next, for the evaluation of y, this is the second sentence. Concentration of B doubles, the rate remains same. Here the concentration of A is not mentioned. It is kept constant or it is isolated. Then the equation will take the form. For this one, for this sentence, the equation takes this form. Concentration of A kept constant. So R is equal to K dash into B to the power of I. Rate of reaction is a function of concentration of B only. So read the data. When the concentration of B doubles, the rate remains same. When B equals to this concentration of B, R, rate is R. When the concentration of B is 2B, rate same, no change in rate. Therefore, R equals R. Two equations. So divide this by this and simplify, you get like this. R cancel, 2 to the power of 5. Here base is 2. Can we express 1 as a base of 2? 2 to the power of 0, anything to the power of 0 is 1. For simplifying, therefore y equals 0, exponents are equals. The value of y in this equation for this data is 0. 0 order with respect to B, first order with respect to A. So the overall order of reaction is what is that? This is R is equal to generalization. Overall order is first order reaction. Similar calculation for this data, experimental data, for this equation. Here, concentration of A doubles, the rate increases by 4-fold. Again, B is kept constant. This is of this equation. So this is the equation when the concentration of A double, rate increase by 4-fold, 4 times increase in rate. So when A equals 2A, R equals 4R. So there are two equations. Simplify. 2 divided by 1. 4R by R is equal to R cancels, 2 to cancel, 4 equals 2 to the power of x. What is 4? 2 to the power of 4 equals 2 to the power of 6. Bases are same, exponents must be equal. So x equals 2, value of x is evaluated. In the same way, let us evaluate the value of y. There is a data concentration of B increased by 4-fold. The rate doubles. Here concentration of A is not mentioned. Concentration of A is kept constant. That is that into K is equal to K dash. R equals B to the 4. Is a R. Rate of reaction is a function of B only for this data. Read the data and put the data into the equation. Increase by 4-fold. B by 4. Rate doubles. Increase by 2. R becomes 2R and B becomes 4B. Into the equation simplify. This by this. Now we get this. 2 equals y to the power 4 to the power of y. We can write 4 as a base 2. 2 to the power of 2y. So 2 to the power of 1 equals 2 to the power of y. 1 equals 2y. Exponents are equal. Y equals 1 by 2. So value of y is the fractional value. So rate of reaction is this one with exponents. So overall order is 3 by 2. So this is how you can evaluate what is that values of x and y from the experimental data. This is general experimental data is that. So problems are like this, most common in examinations. Thank you.